The diagram below, it shows the graphs of gx is equal to 2 over x plus p plus q, and f of x is equal to log 3x. So y is equal to -1, and it is the horizontal asymptote of g. B has the coordinates 1 and 0 and is the x-intercept of f. A, having coordinates t and 1, is a point of intersection between f and g. So just put some pen to paper now. We've got our horizontal asymptote here, y is equal to -1. We've got our x-intercept here at b, and a being the point of intersection between the graphs of f and g. Now we've got a log here, a log graph that is the inverse of an exponential graph, and we've got our g graph here with the fraction, so 9 times out of 10 that is going to be a hyperbola. We can definitely see that. The vertical asymptote of g intersects the x-axis at e, so somewhere there. The horizontal asymptote at d, so d is the point of intersection of the two asymptotes, so where the asymptotes cross, and OB is equal to BE. Okay, so if that's the origin, B has the coordinates 1 and 0, and B is literally the midpoint. Look, OB is equal to BE. So if 1 is the midpoint between 0 and whatever this is, surely this is going to be 2, right? Because 1 is between 0 and 2. Does that make sense? So E would have the coordinates 2 and 0. So 5.1, write down the range of G. So range of G, quite simply, is just going to be y is an element of the reals. Remember, this is the range of our hyperbola. But it's not just y is an element of the reals. We have to put a restriction here because, well, we've got a horizontal asymptote here at G. So it's all the numbers, all the real numbers except the asymptote. So y is an element of the reals and y cannot equal -1. Okay. 5.2, determine the equation of G. So to determine the equation of G, we need to sub in a random point here. Okay, so something for x, something for y. We know what q is. Q is equal to -1. We just solve for that. That is our horizontal asymptote, was given. So we're going to sub in a random point. But does that random point exist? Is it anywhere? Well, unfortunately not. We've only got 2 points on our G graph. Remember, this is our G graph. So we have the coordinates of A, but x is equal to t and y is equal to 1. No, that's not a definitive point. Maybe if B was on the G graph. Anything on this side? No, nothing. So we can't sub in a random point to get the equation of G, but we can use D. Because D would give us the point of intersection of the two asymptotes. So that would be our P and Q values, and that's pretty much all we need. So if we just take a look here, top right, everybody, 5.2, open the bracket. We know what the coordinates of D are. D has the coordinates, an x coordinate of 2. We just calculated that as B is the midpoint of OE. So D has the coordinates x is equal to 2 and y is equal to -1. Okay, that was given in the first bullet point. And yeah, now we can just sub that in. So it's going to look something like this. And that's it for 5.2. For 5.3, calculate the value of t. T is the x coordinate of A. How could we possibly calculate that? Well, now we can utilize our logarithm, our f of x graph. Now, A is the point of intersection between B and F. So in other words, A lies on F. So we can just sub it into our log and solve. So let's do it. So that's 5.3. F of x is equal to log 3x. And now we can just sub in x is equal to t and y is equal to 1. So we sub in our y value here and our t value log 3t. And all we need to do now is solve for t. Remember, that represents your base. This represents your exponent. And that, so I'm just going to correct that. So this is our base. The t is going to be our value and the 1 is going to be our exponent. Okay, just making it look a bit neater. So let's just rewrite it. So this is our base. E, that's going to be our exponent. So 3 to the 1 is equal to t. So 3 to the power of 1, just t is equal to 3. And that is it for 5.3. Okay, so just rearrange your log. Okay, I'm just going to clean the screen quickly. Question 5.4. Write down the equation of the inverse of f. So the inverse of f in the form y is equal to. So to find the inverse of f, we need to swap our values. So that's f of x is equal to log 3x. Remember, f of x is y. So we're just going to swap our y and x values. So swap them. So x goes here, y goes there. So x is equal to log 3y. And now we need to isolate our y value. So remember, that's the base, that's the value, and this would be the exponent. So if we rewrite it, our value, which is like our answer, y is equal to the base, which is 3, and our exponent, which is x. And that's it for the question.